Hello, and thank you for coming today. I'll be talking through a couple of cases where a SugarCRM vulnerability led to AWS accounts being compromised. To start us off, how many of your organizations have a cloud environment? Can I just see a brief raise of hands? Okay, quite a few of you. And how many of you have thought about the unique attack surface that exists in the cloud? Can I see another raise of hands? Okay, not as many of you. So today we're going to talk about how the attack surface is different in the cloud and talk about some remediation steps that organizations can take to protect themselves. For a brief introduction, my name is Margaret Zimmermann, and I'm a cloud incident responder at Unit 42. Unit 42 is the incident response, proactive security services, and threat intelligence arm of Palo Alto Networks. For a brief description of what I do day to day, whenever we have a case come in that has any resemblance of a cloud component, I'm brought in to make sure that we consider the unique attack vectors and unique services that exist in the cloud. At a high level, we're going to be using the MITRE ATTACK Matrix to guide our walkthrough of these cases. We'll start with the initial attack vector, which was the SugarCRM vulnerability, which is CVE 2023-22952. And as a brief note, this SugarCRM vulnerability is what was exploited in these cases, and it's not an AWS vulnerability. In fact, these SugarCRM vulnerabilities could have been exploited in any cloud environment. After this, we'll walk through the rest of the cases and talk about some remediation steps that organizations can take to protect themselves. Of the 14 MITRE attack tactics, we'll be looking at 9 of them. I've included the 9 that we'll be looking at in the order that we'll talk through them. Let's take a look at that SugarCRM vulnerability. SugarCRM is a customer relationship management system that focuses on cross-team collaboration. And it has a ton of different features, such as a quote management system, tools for sales forecasting, and marketing campaign tools. Because of this wide range of features, they obviously have a wide range of customers, such as customers in the audio industry, clothing retailers, as well as financial service companies. Digging into the threat actor mindset a little more, there's various reasons why they target different companies and software. In the case of SugarCRM, it's actually the customer databases that are most interesting to threat actors. Within these databases, there's email addresses, contact information, account information, and quote details. All of these things threat actors are super interested in, and if they were to compromise the database, they try to sell this information or turn around and try to extort their victims for more money. According to the NIST National Vulnerability Database, this vulnerability was initially published on January 11th, 2023, with a base score of 8.8. This vulnerability allows threat actors to inject custom PHP code into the email templates module due to missing input validation. I put a red box around where that module fits in with the rest of the SugarCRM modules. Now, this is a remote code execution vulnerability, so once it is exploited, the threat actors have direct access to the underlying servers running the software. And in our cases, those were Amazon Elastic Cloud Compute instances, which you can think of as a virtual machine. Because these servers are hosted in an AWS environment, this leads to unique attack vectors that we're going to talk through. Once a threat actor gains access to an EC2 instance, in order to gain further access to the rest of the AWS account and move laterally to the control plane, they need to compromise credentials. There's a large difference between threat actors that can compromise the data plane versus the control plane. You can think of the data plane as providing the core components of a service, such as the running of an EC2 instance or placing an object in an S3 bucket. The control plane is a layer above that, and it controls the creation of resources as well as provides the APIs used to interact with the various services. If the control plane is compromised, that greatly expands the attack surface for a threat actor. What we saw in our cases was that these SugarCRM EC2 instances were compromised, and from there the threat actors were able to grab access keys off of the hosts. Those access keys belong to AWS Identity and Access Management users, which allowed the threat actors to get to the control plane and modify relational database service resources, as well as EC2 resources. Let's take a look at why it was so simple to find those credentials in the first place. In these cases, the threat actors were able to obtain long-term access keys from the credentials file located on the host. AWS provides documentation about the different prefixes associated with each resource type, as well as the location of this credentials file. The long-term access keys that we're interested in start with the 4 letters AKIA, and this credentials file is located under the hidden AWS directory under each user. It really depends on how you authenticate to AWS, and depending on how you do that, different credentials will be left in this file. I've included an example at the top of the screen of what this credentials file looks like. One thing you will know is these credentials are stored in plain text. So if the threat actor were to compromise the host and this file existed on the host, it's super easy to just open it up and grab whatever in there. These credentials are exactly what the threat actors need for lateral movement. Let's take a look to see what the threat actors did next in the discovery phase. The first command we saw the threat actors run before doing anything else was this get caller identity command. We see this over and over in cases that this is always the first call that a threat actor performs. You can think of get caller identity as the who am I of AWS, and it returns various details about the role or user that performed the call. I've included an example response on the screen, and it returns the user ID, which is the unique identifier of the entity that performed the call, as well as the 12-digit AWS account ID. And it also returns the Amazon resource name, which contains the 12-digit account ID, as well as the human-readable name of the user or role that performed the call. This gives the threat actors a good baseline understanding of what credentials they have compromised. From here, the threat actors moved on to scanning. To determine what existed outside of the compromised EC2 instances, the threat actors used a variety of tools. The first one we saw them use was Pacu. Pacu is an open source AWS exploitation framework that is designed to be the Metasploit equivalent in the cloud. Now, with Pacu, what was super interesting was it actually already existed on the hosts, either due to penetration testing activity or other user activity. So the threat actors just lived off the land. Now, with Scout Suite, it is a security auditing tool traditionally used for security posture assessments of cloud environments. Unlike Pacu, Scout Suite was not downloaded on the hosts, and we saw that the threat actors used it based off of the user agent in the CloudTrail logs. And again, I've included an example of what that user agent looks like at the bottom of the screen. With both of these tools, the threat actors are able to get a good lay of the land of this AWS account. With these tools, the threat actors scanned a variety of services. We saw describe and list commands for all the different services such as EC2, S3, IAM, and the list goes on. What's most interesting, though, is actually the organizations and the cost and usage service calls. Now, why would a threat actor be interested in these services? There's actually some unique information that you can get from them. AWS Organizations is a centralized place to manage multiple AWS accounts and resources. Of the AWS organization calls, 3 of them stand out. The first one is the list organizational unit for parent. This returns all the organizational unit IDs. The second one is this list accounts, and this returns all of the account IDs for each of you. Now, this final one is the one that's the most interesting. It's the describe organization API. And this returns the master account ID as well as the root email address for that account. The email address is exactly what the threat actors need if they want to try to log in as root. And it's a kind of a big deal it's so accessible because there's no limits to what the root user can do. The final piece of the discovery phase is this get cost and usage API. It might seem strange, but it again provides some interesting account details. On the left, I've included an example of request parameters. And from the CloudTrail logs, we can see the time period that the threat actors requested, as well as the granularity of metrics. On the right, I've included an example response. When reviewing the results, you can tell the general spend within an AWS account. With that spend, you can actually tell how active or not an account is. If there's a large amount of spend within an AWS account, that means there's a ton of resources. So if you're a threat actor, you know that there's a ton of resources that exist. So if you spin up anything new, it'll most likely blend in. On the other hand, if there's a small amount of spend, that means there's not a lot of resources. And so the threat actors know that if they spin up new resources, it'll stand out a lot more. With both of these services, the threat actors now have a good understanding of the account structure as well as the usage within these accounts. And this is a great example of why the attack surface is different in the cloud, because these seemingly innocuous API calls actually provide some helpful information for a threat actor. Let's see what they did next. The threat actors progressed from performing discovery against all the account to taking action on various services. From the discovery calls against the RDS service, the threat actors were able to get database names, what security groups were attached, as well as names of snapshots. This allows the threat actor to narrow their focus to specific RDS databases of interest for data exfiltration. We finally see the threat actors progress to taking action. We saw them laterally move from the SugarCRM EC2 instances to the control plane and modify RDS resources. We first saw them create brand new snapshots from the running SugarCRM databases, and from there we saw them modify pre-existing security groups that already allowed port 22 for that SSH access, and we saw them add port 3306 for MySQL. After this, the threat actors moved on to exfiltration. They used those snapshots they had just created to create brand new RDS databases and made them publicly accessible. From here, they attached the security group they modified. They also changed the master user password to let them log in. Now, luckily for us as incident responders, these snapshots were not deleted, so we know exactly what data was publicly accessible. On the other hand, we were not able to tell how much data was exfiltrated depending on the case. So the organizations that had VPC flow logs enabled, we could tell exactly how many bytes left the network. With the cases that did not have it enabled, we were unable to tell exactly how much data left the network. One thing I wanted to note that was kind of fun was during the discovery phase of the attack, everything was clearly automated because it happened very quickly in a short time span. Once the threat actors moved beyond exfiltration, the time between these APIs took a lot longer, and we actually saw a bunch of typos. So it's kind of fun to see the difference between the automated discovery piece and then the hands-on keyboard rest of the attacks. The threat actors also did a lot of work on the EC2 instance side of things. From these API calls, they're able to tell the names of EC2 instances, the network setup, as well as what security groups existed. This gives the threat actors a good baseline understanding of where to start modifying resources for EC2. The first thing that we saw the threat actors do was create a brand new Amazon machine image from the running SugarCRM EC2 instances. From there, we saw them import a new key from their public key pair. Now, what do you do with an AMI and a key pair? You create a brand new EC2 instance. And that's exactly what the threat actors did. They also attached the pre-existing security group that already allowed port 22 for that SSH access. Now, the threat actors did not just do all of their work in the same regions that these organizations had their infrastructure. They actually changed regions to non-used regions and performed actions there as well. The first thing they did was create a brand new security group that allowed port 22 for that SSH access. From there, they re-imported a key pair, and because it's a different region, they couldn't use the key pair they already imported, so again, they had to make a new one. And with that, they created a brand new EC2 instance. But this time, they used the AMI that was publicly accessible from the AWS Marketplace. One thing I do want to note is that these threat actors did not have to create new VPCs. They used the default VPCs that are available in every region, and they also did not change anything with the network configuration. We'll talk about this in the recommendation section, but this is a great example of why we recommend enabling guard duty and other services in all regions. By default, there's nothing stopping threat actors or anyone else from that matter from creating resources in different regions. And so you want to make sure that your security protections are in place accordingly. For the privilege escalation portion of this attack, we did not see the threat actors try to create new IAM users like we have seen in other cases. Instead, we just saw the threat actors attempt to log in as root. They did take the information that they obtained from the organization API calls, and they used that to try to log in as root. Luckily for these organizations, those root logins did fail. I've included an example of what the CloudTrail looks like for that failed login. And luckily for us as incident responders, when you're looking at these CloudTrail logs, the root logins stand out. Beyond logging in, attempting to log in as root, these threat actors did not do much in the way of persistence. The most clear attempt was creating EC2 instances in different regions than the rest of the infrastructure. Organizations typically pick 1 or 2 regions to host the majority of their infrastructure. And so when you're in the AWS console, there's no reason to switch to different regions to see what resources might exist. And so this does enable longer persistence for the threat actor. Again, similarly to those root login attempts, the new EC2 instances in different regions greatly stood out in the CloudTrail logs. With these attacks, there's different time periods between when the compromise happened and when these organizations knew that they had an issue. And this is exactly when the threat actors need to be stealthy in order to evade defenses. We saw them deploy resources in non-standard regions, but we also noticed that threat actors turned EC2 instances on and off. There's a couple reasons they might do this. The first one is visibility. When you're in the AWS console on the EC2 page, it defaults to showing only running EC2 instances. And so unless you're explicitly looking for non-running EC2 instances, the threat actor instances will stay hidden once they're in a stopped state. The stopped state also serves the dual purpose of not incurring extra costs. If an organization has tight notifications around costs, once an EC2 instance is placed in that stopped state, it does not incur extra costs and is another way to evade defenses. In these cases, we did not see the threat actors attempt to perform other defensive evasion techniques, such as stopping CloudTrail or disabling guard duty. That wraps up the case walkthrough. At a high level, we saw the initial compromise with the SugarCRM vulnerability, and we saw the threat actors grab access keys from the compromised hosts. This allowed them to move laterally to the control plane. These keys were stored in plain text, so super easy for the threat actors to grab them and then use them for discovery activity. The most interesting piece around discovery was the organizations and the cost and usage API calls. From there, the threat actors made public RDS databases, as well as created resources in a bunch of different regions. We also saw the threat actors stop and start those resources to attempt to evade detection. And finally, we saw them attempt to log in as root for privilege escalation. For the attack overall, we saw the cases take anywhere between 21 and 27 days. But for the AWS-specific portions of these attacks, they took only between 2 and 4 days. For our remediation steps, we're going to cover a few different topics. We're going to talk about various ways to protect those access keys, as well as the importance of writing granular IAM policies. We'll also talk about the importance of monitoring root, as well as enabling other security services. Let's start with how to protect those access keys. We constantly see access keys be the root cause of these AWS cases, and so it is vital that they are used correctly. I would love to say just don't use them, but that's not the world we live in. Tons of applications and processes still depend on hard-coded access keys, and so this is the fine line between usability and security. What we recommend, though, is not storing them on the host themselves. If someone does log onto a host and they store credentials in this credentials file, we recommend that they clean up after themselves when they're done, or a process exists at an organizational level that goes through and cleans up these credentials files. That way, if a threat actor does compromise the host, there's not access keys lying around. We also recommend that you rotate them on a schedule. The longer lived an access key, the more chance it has of being compromised. And so you want to consistently rotate them and delete unused access keys to help protect your AWS account. The best part is all of this can be automated. Along the lines of access keys, we have to talk about permissions attached to users. The threat actors were able to accomplish all that they could in these cases due to expansive permissions attached to these users. I know it's much easier to write wide open policies and permissions, but it's absolutely worth spending the extra time to write and maintain narrowly scoped permissions to help protect your AWS account. I will say there's a ton of resources online for how to write them, and AWS has their IAM Access Analyzer tool as well. But one thing I do want to note is that if a product says that they need expansive permissions, such as the example on the left where it looks like service star, it is not worth the security of your account to not narrow the scope of those permissions to exactly what this user needs, such as the example on the right. One thing we also recommend is enabling monitoring around root. It should not be used other than a handful of account management tasks, and so it's a super high fidelity for your most valuable account. On the left is a CloudWatch metrics that AWS provides that you can turn into an alert. And as a side note, please, please, please always enable MFA on root. There's no restrictions to what root can do, so you really want to protect it with MFA as well as a long password. And last but not least, let's talk about logging. There were gaps in these cases due to insufficient logging and security services not being enabled. We can always pull the default 90 days from the Lateral API, but it's a lot more helpful to have a full history of an account. We also recommend enabling guard duty and making sure those alerts are actually sent to teams that will respond to them based off of severity. In the cases that had guard duty enabled, it did indeed catch these access keys that were compromised, and it's just another great way to protect your accounts. With both CloudTrail and guard duty, we recommend enabling them in all regions. Again, as you saw in these cases, the threat actors did not just stay in one region, so why would you only try to protect and monitor the regions that your infrastructure are in? We also recommend that you enable VPC flow logs. Again, you saw that was super helpful for data exfiltration, but it's also helpful for general network troubleshooting. For all of these logs, you do want to make sure you have a good retention period. Compromise can even happen in your development account, and so you want to make sure that you have the logs around long enough so when you do recognize you have an issue, you have the logs that you need to help respond. Before I wrap it up, I wanted to cover a few key takeaways. You always want to make sure that you clean up and monitor those access keys. They're extremely valuable in AWS, and you want to do what you can to protect them. You also want to make sure to monitor for abnormal activity. In these cases, everything that we talked about today was visible in the CloudTrail logs, and it's all detectable. So you want to make sure that you stay vigilant for when this does happen in your account. You also want to make sure you enforce granular permissions. If the organization has scoped the permissions for these compromised users to exactly what was needed in these cases, it would have stopped these threat actors in their tracks. That wraps up my presentation for today. I hope you enjoyed it and learned something new along the way. Thank you.